So today I am thrilled to have a very special guest, Mr. Tim Floyd. Tim is an architectural materials scientist and a chartered surveyor with extensive expertise in timber decay. So welcome to the podcast, Tim.
Hello, Vincent.
So it's a real pleasure. I've actually had the pleasure to work with Tim on several projects in the UK. And we also had that incredible trip in Ethiopia where we went out and looked at some of the world's oldest standing wooden structures, which I think, when was that? 2018, 19?
Pre-COVID days, wasn't it?
It was just about. I think it was 2019.
Yeah. And then Spain the year after that,
which was a ICOMOS. They were both ICOMOS led trips, weren't they?
Yeah, fantastic, both of them. And of course, the York one, that was the first one that we did together.
Yep, that's where we met at the ICOMOS conference in York. So yeah, it's been great. Now, I'm really excited today to discuss today's topic. Now, I know, Tim, that you cover a lot of other materials like stone and plaster, etc. But I'd like to mainly focus today on timber decay. Can you just start by giving the listeners a brief overview of your background and some of your achievements, please, Tim?
Background, well, I think as a lot of people in heritage, you've got a very strange entry point into heritage, and mine was a bit of a strange one. So I started off in construction, civil engineering, and then got a bit despondent with all of that, went traveling for quite a few years and got interested in heritage out there, and came back, and I just found a degree in Bournemouth that did building conservation, did the degree there, then went on to specialize in architectural materials science in a master's, and then was couple of years after that was very lucky to have got employed with Dr. Brian Ridout, who is he's still in the background with English heritage, but doing a lot less nowadays. But he was the guy that really pushed forward this idea that you could manage and understand an environment to use as a way of controlling and monitoring decay. So I mean, as goes notable parts of my background, he was getting a job with Brian back in the early noughties. Ever since, I've been very lucky to have been involved with some really high profile buildings, cathedrals. Been incredibly lucky.
So you had an interest when you were quite, fairly young, in your teens, with building conservation then, would you say?
Yeah, my first job was labouring on a building site. I left school at 16 and was just swinging a pickaxe for the first couple of years of my professional life. Because as a young man, it just so happened that I went to the local building site, started labouring, and then started working with a local builder who was doing a lot with Cotswold stone and lots of vernacular construction. It's just very organic, the way that the interest started. I went to college then and did the wrong thing. I did civil engineering and ended up on roads and bridges and pipelines, and just didn't like it. Just got thoroughly despondent with pumping cubes of concrete in every single part of the country. So yeah, a few years traveling sorted that out and got me back on the track into heritage. But that sort of moved on. I mean, we're talking about heritage today, but it was more, and it still is, material science where it overlaps a building. And so I'm looking more and more modern constructions now, because the discussion we're having is about decay. Therefore, it's a discussion about timber, and use of timber is going through the roof at the moment. Pardon the pun. But because of its its eco credentials and its good CO2 footprint for carbon locking, everybody's using it, and everybody's using composites and glue lams, and which incidentally we did a long time ago, but that's another story. So yeah, I mean, it's heritage now, and a lot of new build as well, with analyzing how timber responds to its environment, basically.
So let's talk about your role as a timber decay specialist. What does it involve? What are your primary responsibilities and tasks, would you say?
So, I mean, obviously, it's generally for the stakeholder, unless it's research. Somebody owns an asset and they want reassurance of its condition. Quite often, how our positions as timber consultants, where they've come from, is we've been born out of an overzealous remedial industry. I'm not going to start knocking the remedial industry, but in years gone by, let's say up to sort of 50, 40 years ago, the idea was that you would just, if there was a problem with the timber, slightest bit of problem with any fungal decay or any insects coming out of it, it was just all ripped out and you started again. That's the way we used to do it. But thanks to initially quite a small group of people, sort of 30, 40 years ago, I call them the first generation building conservators, we take a much more delicate line on it now. Coming back to your question, my position is really understanding, let's take a bit of wood in a building. I mean, there's some overlying biology to it. It's got a crack in it maybe, or a fracture, or there's some insects have come out of it, or it's damp, or it's wet. The client would be looking to somebody like me to say, well, what can I do with this timber? Is it okay? Can it stay there? Do I need to strengthen it? Do I need to cut it out? What happens when I dry it? All these things, what chemicals can I put on it? It sounds very simple. You've just got a bit of wood that's decaying in the wall. But there's a whole range of things that overlay that equation. So like, what's the species of the timber? How wet has it got? What's the decay organism we're talking about? What environment is the building going to be in? Are you going to repair the roof and the building's suddenly going to dry out? Is it suddenly going to get wet? So it's really drilling down into the sort of fine details of the timber, the agent of biodeterioration, the environment, levels of moisture, and then coming back to the client and saying what we would recommend they do. And obviously sometimes you're interfacing with decorative plaster or stone. You're never just talking about the bit of wood. There's always the interface of all the other materials around it. You've got to take a step back, see how the whole system's working, and then come right in close and start picking apart.
With my job, you have to have your detective's hat on. Poirot. When you, because like you say, it's not just one particular thing. You have to go in and look at the whole, the bigger picture to see what's happening.
Yeah, I mean, the detective thing is quite interesting because it's always, I mean, I call it event chronology. When you have a big asset stood there for 200, 300, 400 years, there are tens, if not thousands, of technicians that have been all over that building at various points in its life doing different things to it. And we're not always party to everything that's happened. And so quite often when somebody like me comes into, if I'm brought to look in at a specific problem, for instance, then there's a whole load of things that's happened. People have sort of like been doing stuff to this, and you sort of got to try and pin it down, find out what's been happening, what chemicals have been put on it. If we're talking about the emergence of a wood borer, something like death watch beetle or furniture beetle, and it'll pop out the end of a beam, and then people will get very sort of animated and worked up that their building's just about to fall to pieces because they've just found death watch beetle. But there's a whole story that's gone on before that death watch beetle's popped out. The adult that's popping out of the wood was probably laid as an egg up to 8, 9 years ago. Quite often that laying event was associated with an event of dereliction or poor condition. So then you'll they'll tell you about this death watch beetle emergence, and it just started this year and we're terribly worried. And I'll often say, was there any work done about sort of 8, 10 years ago on the building? And often there is, they said, oh yes, well, we did it up. It was a wreck and we did it up 8 years ago. And it'll just be a little corner that a little residual population's clinging on to. Or you'll find a massive dead insect somewhere. And it'll be because they were poisoned, but they won't tell you that. They'll just, we've got this great big pile of insects here and we don't know what's going on. And I mean, my point is, it's the detective thing it's so important that you try and find out what happened to these buildings in years gone by.
Did you, I know you said about your studying, but what's out there now, for people if they want to get into the industry?
Well, it's an interesting point because we sort of occupy, so the field we're in is basically built with, we would call ourselves building scientists. So, and we're basically talking about biology at the moment today, but we also do where chemistry overlaps timber, where physics overlaps timber. So, I mean, the reason I mention that is because I think the scientific base is the most important part of this job. It's not that you've come from a building surveying background. It's that you can think scientifically. So For instance, James that started with me recently, he's a biologist, and it's relative, and this is my opinion, and I'm quite happy to be proved wrong, but it's much easier to teach building than it is to teach somebody how to think scientifically. So if they're the scientist, they're already formed scientists, then teaching them the building's pretty straightforward. I mean, buildings, without wanting to oversimplify buildings, because I mean, you can't compare them with a biological organism, for instance. The complexities of biological organism are much greater. So, yeah. So I'm a chart surveyor. I did that because my previous boss was Brian Ridout, who's a doctor, and there was no way that I could go back and I had a master's, but I just couldn't bear the thought of going back to uni for another few years or more than a few years to do a PhD. So my particular path was, there was a research pathway for the RICS. So most of the pathways to become a surveyor or an engineer or an architect, you have to go along very specified career pathways. You have to get your part 1, part 2, part 3 serve in an office, have a diary, fill out requirements from whether it be RIBA, ICE, or RICS. But because we occupy such a niche part of in building conservation, but building science, I would say you need to have a science, ideally science degree, handful of or science A levels. That would probably be enough for you to get started in the field. They want some career progression, and if you're not on the RIBA tracks, or you're not on the ICE tracks, or you're not on the RICS tracks, it's difficult to get professionally qualified. What James might be doing here, we might be trying to sort of pursue a PhD for him in building mycology, because that's quite a hot topic at the moment, and he is interested in he has a specific interest in fungi. So that's probably what James is going to try and do. But no, I mean, I think that's it really. I mean, what we do, building scientists need a science background really.
But what I like about your approach is that it's a holistic approach. I really like that, that you work with nature and you don't start panicking.
Absolutely.
Going into buildings and go, oh my God, this is, that's so refreshing when I've heard you speak. We've been at various lectures, and it's great because it's,
it's so important, I think, at the moment with the environmental problems that are going along. We need to get back to the fact that we're in a biosphere, and our homes are little ecosystems in their own right. They shouldn't be. These hermetically sealed units that are sterilized, that's a bad thing. Obviously, you don't want dry rot to completely rampage through your ground floor so you fall through it and break your neck in your basement. Of course, I accept that. But there's a fine line here. So going back to the ecosystem analogy, it's a balance, as is everything in life. And I think as soon as you start to try and sterilize, destroy, scorched earth policy, and that includes with wood borers, you're going to upset a balance. And all this thinking sort of came from Brian Ridout, my old boss. He was an out-and-out entomologist. That was his route into heritage. And he understood this. He understood about ecosystems keeping themselves balanced, and as soon as we come in with our size 13s and start sort of like trying to control a part of it, it completely messes everything up. I mean, Nate, as I said, we've got to keep ourselves dry. Of course, you don't want water pouring in through your block gutters. You don't want rising down. You don't want water sort of like capillarizing up the wall bases and making the edge of your shag pile carpet moldy. Of course you don't. But there's a happy medium. That doesn't necessarily mean killing everything in the house, killing every single creepy crawly. You're going on the wrong path there.
Yeah, and I find a lot of people that purchase period properties, they want the period property, but they want it to act like a modern building. And that sometimes isn't the case. My house is 1840, and as you know, there's some areas of damp within it, and sometimes you just have to live with it. It's sort of part of the building. And when you start trying to fight that and make it dry and draft proof, that's when you can get the problems.
Yes, yeah, and you'll probably end up losing in the long run.
Yeah.
I think it's people's eyebrows are still raised when they're expecting my first recommendation. So they'll ask me to come, and if they'll have what they consider a problem with some timber decay or some insect activity, or they found a fungal growth or some mold or something. And their instinct, they almost say it to me on the phone, I need you to come around and tell me what chemical I got to use. That's all I want you to tell me. Just tell me what biocide. Just tell me how to kill it. And in a way, it's sort of like, it's you. We're all. I might be going off on a bit of a tangent there, but my point is we've got to try and change this thinking of killing things with a biocide. It's all about environmental management, and again, it goes back to these sort of pioneers of conservation, of which my old boss was one, and it's about this term environmental management. And it can be done, and I suppose the other thing about environmental management is it's sort of slow, but so is biodeterioration. People see a handful of beetles and think, kill them now. I want it done now. But that is a process that took years and years to happen, and we can reverse it, and it'll be all right. But it might take a few years of tweaking the building design and possibly changing the way air moves around the building to sort of dry some areas. Yeah. And in the meantime, this residual population of deathwatch beetle isn't going to go hammering through your oak beams and make your building fall down. It's been there for 400 years. It's not going anywhere.
So can you give us sort of a daily routine? It's a typical. I know your days are different every single time, but let's say you're going to visit a period property that has got timber decay or damp. Can you give us a typical example of what a typical day looks like? What do you do? You get to the building, and what tools you have, and just try and give us a bit of an insight into that.
So typical day. Well, I suppose we've just come back from Ramsgate, where we've been for 3 days. I suppose this is the reason I'm going to use this example, is because it's fresh in my memory to give you sort of a normal working day. So we've spent 3 days down in Ramsgate on the harbour, looking at 3 wonderful buildings: Clock Tower, a building called Smack Boys, which is where young boys that went out onto the smack boats fishing were housed, and then there's a sailors' church. So they're all sort of like mid to late 19th century. So it was timber and damp surveys that Sanet Council asked us to go down and have a look. There are some particular problems. A couple of them I sent to you with some windows and some decorative joinery. But so we drive down there. Usually we're staying overnight, because we obviously got to go to where the building is, and you just can't. Doing what we do, which is relying on what you're seeing in a building, you can't pitch up to a site knackered after like a 2-hour drive around the M25, because you miss things. So anything further than about an hour and a half away, we'll get to the night before. And then we don't look like your normal surveyors. We will look like 2 labourers, actually.
I know it can be messy, your job. I've seen some images and pictures of you climbing in roof voids, and
so we quite often like draped with cobwebs and sort of like bits of dust in our ears and things like that. So we've basically got to crawl to all of these places that people don't usually go to, because that's where the business end of a building is. It's the buildings, especially Georgian and Victorian buildings. I mean, in a timber frame, you can sort of see all the connections, and it's quite easy to sort of pick up. In the Georgian and Victorian buildings, there's like ceilings and floors and wall panels and like underslung ceiling, underslung roofs. And we've just got to we've basically got to give the insurance to the client that all of that's fine. So we'll be crawling around.
Sorry to interrupt. So you're crawling around, but then you've obviously got some gadgets and
We have to acquire data. Yes.
You have to acquire data, that's the one.
Yes. So that's generally in the form of, let's say, for instance, timber. The most important thing with timber is what its moisture content is. So we'd be doing things like taking timber moisture contents. We'd be finding out what the density of the timber in concealed areas is, like where a timber is embedded in a wall, or if you have a connection, a mortise and tenon connection. And the way we can get to those hidden connections is using a micro drill, which is a machine that drills a really thin probe through the timber and measures density. We would use things like that. We would use thermography. So we carry a thermal imaging camera. That's quite useful. That's sort of like put out as being a good diagnostic tool for damp. I would argue with that, but where it does come into its own is when you're trying to find out build-up of layers. You know, where a stud is, where a rail is. It's really good at doing things like that, and so we might use that.
And am I right in saying that thermal imaging is the bluer it is, the more the damper it is? Is that right?
The thermal imaging camera is measuring the energy that's given off by every surface, and how that energy is given off is affected by things like water evaporating. If water evaporates off a surface, that takes energy from the surface. So the energy reduces on the surface, which is picked up by the thermal imaging camera, and it will give you a pixelation on a photograph.
I remember you saying it before.
It's picking up energy, and we're interpreting what those variations in the energy is telling us. So we're sort of saying if there's a dip in the energy right there, it might be due to water evaporating off, so it might be due to the fact that it's damp there. But it's just the energy is given off by everything. And as I said, we use it more for trying to pick up building materials underneath other building materials. There will be a sort of an energy gradient on the surface. So for instance, if you've got sort of like stud work over a timber frame and you're trying to pick out where the timber frame is, it's really good for things like that.
Yeah.
I've also used it quite well for areas you can't get to. We use it really successfully recently in Hay Hall near Wigan. It's fantastic big Victorian, possibly a bit earlier than Victorian. Anyway, it had this great big dome above the central staircase that you couldn't get to. And it was known that there was a bit of water dripping there. So we knew there was a bit of water getting in around there. And using the thermal imaging camera, there was actually a great big blue area in one corner of this dome, really stuck out. And further investigation, we opened the roof up from above and went down in, and all the ribs of the dome had been decayed by dry rot. And so they're in the process of we're trying to repair the dome ribs. The trouble is there's in fantastically ornate plaster on the underside of the dome, and the ribs that it's all adhered to, the ribs are all decayed in the wall. So at the moment, we're trying to develop a way that we can possibly leave all the plaster in place. And I mean, my idea is to try and use some sort of plaster of Paris. So putting a load more timber above it, and then sort of use maybe Hessian or steel mesh to sort of go off the timber down onto the decayed upper face of the dome, and then just like pour plaster of Paris on. Very kitchen sink, but yeah, that's a tough one. But I mean, we found that through thermal imaging. That was quite good.
Okay, so you're calling around, getting very dirty. You're using certain technology to gather your data.
Yeah.
And obviously a lot of photography as well.
Yes.
And then, so once you've got all that and you've finished on that particular project, then what's next? You have to produce a report and send it to the client.
Yeah, so our reports are very visual. I found that sort of old-fashioned report writing is like reams and reams of text. What we do is we use photography a lot. So our reports are basically schedules of photographic observations. So we'll have a photograph and some commentary on it. And then that photograph and bit of description will be referenced to the part of the building on a plan at the end of the building.
Much easier to read.
Well, I still have, yeah, I mean, it's amazing that some sort of old school practitioners and professionals, they're still from this world where digital photography wasn't a thing. And so their training and background is all about just reams and reams of text. So they'll just go badumph with their report, and it's sort of like 50 pages of just text. They do sometimes put photographs in as an appendix at the back, but as soon as digital photography became very easy and quick to be able to embed it in a report, I was just sort of straight on it, and very quickly our reports became very photographic. It was just like pages and pages of photographs with commentary, rather than the other way around, rather than like lots of text with the occasional photograph.
Yeah.
So it's all very, very visual based. And then there'll be sort of like sets of recommendations for how they should approach any remediation. We'll give suggestions about repairs. I mean, usually that's down to the structural engineer would give you the detail on how you're going to repair it, in terms of what grade of bolts, the centering of the bolts. But we would give a load of options. And so we would say, for instance, the timber's decayed in the wall and out 40 to 200 millimeters, where it recovers full section. A repair, because it's not going to be seen, a repair could be done with a plate or a flitch or a bracket or something. If it's going to be seen, we would then possibly say sort of like a hidden flitch or a scarf. Or so we would sort of like, we steer the client in directions and give them options about how they can approach it. And also with the materials that they've got to source for repairs, we're sort of involved with that quite a lot.
There's a lot, isn't there, involved, because you're not just doing the scientific bit, you've got to have your craftsman's head on as well, and you've got to understand sort of multi-disciplines to be able to give advice, really. I think.
Absolutely. So just for the point of view of, let's take the simple thing of this bit of wood's been damaged, it's got to come out and it's got to be replaced. So there's strength and species, which are obvious. Very often they're interdependent. So we would have to do a species check. So when you're determining species of different timbers, unless it's something like oak or elm, which is a hardwood, which is easy just to sort of sand the end grain, look at it and say, well, this is oak, this is elm. If it's a softwood, if it's a pine, that it's not the easiest thing to do. And to give a definitive take on species, you've got to thin section it and look at it under the microscope. So we would do that. We would confirm to the client species and quality, so that you could do a certain amount of in situ strength grading. There's some standards, but which tells you how to sort of like assign a structural capacity to any timber. So we would do things like this. And yeah, so as you say, it isn't just a question of saying this bit of this bit of timber is sort of deteriorate, needs to come out. You've got to tell the client exactly what it is, what strength it was, what species it was.
Yeah.
And often where they can get replacements, which is really difficult, especially as you know, in the case of something like Baltic pine, which comes from a natural stand. I mean, that stuff is very, very difficult to get now. And often they just get Douglas fir instead, because it's just too difficult to get naturally grown Pinus sylvestris. But yeah, I mean, yeah, you're right. And it's not just go down to the local builders merchants and get a new bit of wood.
What would you say some of your most interesting projects have been? What really stands out? What have you really enjoyed, or what was bizarre?
Well, the things that are really sort of interesting me at the moment is timber composites is one. So, and that is heritage as well. I mean, so timber composites in the terms of, well, I mean, first of all, I'm lucky enough to have been involved with lots of high profile buildings. Like a number of years ago, I lucky enough to survey a couple of roofs at Canterbury Cathedral, and we've done a lot of work at Highclere Castle, where they filmed Downton Abbey, and York Minster. I've done a bit there, and I mean, but so the point I'm making is that there's high profile buildings which are great and wonderful to be at, but there's also, in my mind, the sort of like the more unusual. So the unusual is things like timber composites used in heritage. So timber composites is when you get lots of different bits of wood stuck together to make a whole unit.
So like a ply, so like a big pieces of wood sandwiched together.
Exactly, and it's not as some people think. It's not just a modern thing.
No.
I mean, we found nailed glulam arch braces in a swimming pool in Manchester from 1880. There was another building I did where I found these laminated arch braces. And what they started doing in the 60s and the 70s, possibly a little earlier, is they started doing hyperbolic paraboloid roofs. So
What
these
on
are
earth is that? Can you explain to our listeners what those are?
hyperbolic paraboloid roofs. So if you imagine,
That's a mouthful.
I either imagine like, what's the winged, the animal that swims through the sea? We were just talking about it. Manta ray.
Oh yeah.
So there's some roofs that look like manta rays. There's some roofs that look like quavers, and they have curvature in all different planes, and they sort of hold themselves together. And they're built from laminated timber. So there's lots of different timber planks, all going one way, and then they'll do another layer going the other way, and they'll do another layer going the other way, and they build it over very sort of like weird forms, and then it'll take the formwork away and it holds itself together. I'm lucky enough to have been involved with two of those, which were really interesting structures. Unfortunately, the interest came from how they're decayed. So, because the interesting part comes because the structure depends on in this particular case I'm talking about, which was the first one I worked on was a church called Church of the Holy Family in Blackbird Leys in Oxford. Unfortunately, the damage to that had got so bad that I think it's been delisted and is going to be demolished if it hasn't happened already. But that was a hyperbolic paraboloid. It's how they decay. So decay will sort of like shoot along one layer. So it sort of looks all right on the bottom, looks all right on the top, but the decay's preferably gone through one lamella or one layer. And this sort of like upsets the whole structural dynamic of the whole thing. The microdrill is really good for that because the microdrills can go through the different layers and show you where a layer is good and where is bad. There was this one and another one where it's an active conservation job. That's St. Richard's in Ham near Richmond. That's just a stunning roof. That's from that. I think that dates from 1960s. Again, problems with roof drainage. It's decayed at certain points and sort of like tension's been released from some of the lamellae. The structural complexities are immense on these things because they're designed to sort of like hold themselves up. So you see sort of like windows around the outside, but they're not needed. The thing could actually just sit like that on its own. It's difficult to describe. It'd be easy if listeners go and check out those two churches. And there's another one in Warwick that hopefully I'll get involved with soon. I find those very interesting. Those how when you get one bit of timber and glue it to another bit of timber, it becomes very complex. That's what I'm remembering as I'm talking to you. I was involved with Kibworth Post Windmill for SPAB. The microdrill came into own again because the whole windmill is held up on one post, one massive post in the middle. I got involved there because I think noticed a bit of frass or something. So we did this microdrill survey of the post all the way down and found out that there'd been some form of heart rot. It had basically hollowed out at one point. It sort of like hollowed out the middle of the timber. You couldn't see it. If you hit it with a hammer, it's really solid. But it had lost about half its section at its midpoint, this post. I think from memory, we worked out that it could still work structurally, even though it lost that amount of section in its middle. So it was actually sort of like just left.
The heartwood went. Why would that? Because it got really damp, maybe, or
so this is down to the dark and mysterious world of fungi. You quite often see what they call heart rots, like when they cut down a tree in your local park because it's been infected with a certain form of fungus that's going to kill it. You see the cut stump, and the outside of the stump's fine. The decay is just right in the middle. It's just how some fungi work. Some fungi are able to go up the central pith or the juvenile wood, which is right in the center of the tree, and they can start sort of we're getting into sort of like quite dark, deep organic chemistry here. So what the fungus does is is it's able to modify the chemistry of the heartwood, which is usually resistant to fungi and insects. But given enough point loading of water and given the right species of fungus, it can cause a problem. There are certain species of, if you look up heart rot, and there's some types of fungi that exploit knots. So like an exposed knot on a tree where a branch has come off, they can exploit those margins of the timber, or splits.
Yeah.
All the time, finding out, as you say, like a different fungus that's done a completely different thing that you'd expect. Usually we can identify them if there's a fruiting body, mushroom, the reproductive phase. Very occasionally, if we can't, they've got to be sent off somewhere like Kew that can do a DNA test on them if the client so desires. I generally don't subscribe to that sort of thing. I think if you've got a fungus that's decaying your wood, that's sort of all you need to know. But lots of people get a bit nervous about it, and there are some legal cases for surveyors that were sued for not recognizing dry rot. So yeah, I mean, timber composites, that's what I'm really interested in at the moment.
I didn't know that you were interested in that field, so that's good to know. So let's move on to some common questions that our listeners might have. Number one, what would be the primary causes of timber decay in old buildings, and how can they be identified? I know that's very broad because there are multiple, but what would you say?
Effective rainwater goods.
Yeah.
So that would be valleys, downpipes. That's the big one. The second one would probably be external ground levels going up over time because of patios or in churches, graveyards, that sort of thing. And the soil comes up and sort of like bridges your suspended timber floor, and then you get moisture transference in, and you can also have maybe basements that the drainage goes wrong somewhere else on the property, and your basement keeps on filling up with water. That will take the environment up to a relative humidity of 90-100%. You'll get water condensation, start decay there. But those are the two big ones. Hat and boots, usually. Oh, and washing machines and dishwashers, toilets.
I didn't think about that actually, because our house, which is built in 1840, when you look out onto it's got a lovely sort of a brick paved patio. Now, the Victorians designed that obviously very, very well in 1840 for the runoff of water to go into the gullies. But as the ground has changed, some of it is sort of it's going the opposite direction. Things like that, isn't it? That can literally just slightly tweak, and now the water's going in the wrong direction, and you don't realize it until it's too late, and it's gone into all your floor joists and sleeper walls and things like that.
It's a really good point, and I think I mentioned it somewhere on my website. I said something about Georgian Victorian buildings and timber frame vernacular. They're fundamentally well built. When they were put up, when they were built, they had guys doing it that really knew what they were doing. They were at the peak of their trade. Back then they couldn't afford to mess up. It was done right. But as you say, as they've gone through time, and we've added things here and there to them, and of course natural subsidence and a big tree that's caused a bit of ground to come up maybe, and just as you say, just alter a drain by a couple of centimeters. It's very easy for the thing to go completely wrong really really quickly. But that's all down to understanding what's going on, understanding it, and then if you can understand it and you have the will, you can just correct it. Graveyards in a church is possibly more difficult to do. I think always have confidence in the original design of the building. Yeah.
And would you say that, to a degree, modern materials also contribute to this as well? For example, our house would have had probably a lime wash or something on it, and now it's got a horrible modern masonry paint, which is sort of trapping the moisture in. Is there, what would you say, the sort of damage caused by the incorrect materials being used?
I'd say I'm not one of those people, sort of like a Luddite, if you like, that says everything modern is bad. but unfortunately, a lot of it is.
So every modern
paint.
material is bad then?
No. There's, I mean,
No, I know what you
you know, I think it's difficult because you shouldn't lurch one way or the other, because you'll blinker yourself to sort of like good stuff. Quality of timber is the main one with talking about this particular subject, which is biodeterioration. It's just the quality of timber is just not what it was 100 years ago. In terms of talking about softwood, the hardwoods, the oaks we're getting, that's still pretty much of a muchness as it would have been 200-300 years ago. But softwood, which is what we rely on a lot for the construction, it's fast grown, modern silviculture, forced to a certain size in a certain period of time. It gives you a less robust product. I have to be careful what I say there. I use robust carefully because there's lots of work currently going on. The old thinking used to be, if it's a modern bit of wood, it's not as durable and it's not as strong as if it's a slow grown bit of wood. There's lots of timber lab work going on with this right now, and it seems to be suggesting that that's not always the case. With a bit of softwood and lay it down in a damp environment in a basement, I think we all know that it falls apart really quickly, even if it is pre-treated. You know, the active treatment, the active biocide gets washed out of the timber structure quite quickly.
And
paint is another one.
Sorry?
But as you inferred earlier on, paints.
Yeah.
Yeah, I mean, they were a relatively new invention, I guess, isn't it? We had lime washes and pigmented clay washes, but this thing about having binders that you put over a building, I mean, obviously the artists use paint to make paintings for however long, but this thing about covering your house with it, that's well, it isn't. We had this discussion about the black and white of buildings and how painting the timbers black was a new thing that the Victorians had invented. But we were discussing this, they would have used things like pine tars and things. So Little Morton Hall, for instance, was a highly decorated timber frame building, and they would have wanted to have seen that timber framing. That would never have been lime washed. Like the old thinking was that they lime washed the whole thing on the timber frame. Yeah. But Little Morton Hall, that's I think 1600s. The decoration in the timber, how they've carved it, they wouldn't have just like splashed lime wash over that. So this idea of and that used to work. What they used back then, the sort of like the pine oils, seemed to work. But as soon as we come into sort of like the Industrial Revolution,
yeah,
some of the stuff we start throwing on them is byproducts of industry, nasty organic stuff that's not vapor permeable, and high content of plastics or bitumen, or
it's like ultra processed stuff. The organic materials have worked for hundreds of years, and then they started getting very clever and said, oh, if we can do this and this to make it last longer, and like you say, then it's not breathable. And that's when the issues that, along with maybe double glazed units and then masonry paint, all of a sudden you're literally just wrapping this period building and it's not able to breathe and expel moisture in the right areas. And I would imagine back then, the period properties were pretty wet and damp, and it was quite a harsh environment in the winter. But now we don't accept that. We won't go and put a jumper on. We'll crank the heating up and shut all the windows.
Yeah, absolutely. I mean, it's how we use the buildings now. But so the materials thing is, there's a couple of good, I think there's an application for some resins, obviously for metal, for sort of like stainless steel fixings, which are relatively modern. I think there's some sort of potassium silicates, which are modern inventions. There's possibly an application for their usage because they do pertain to have a bit of vapor permeability. Some of the people in the groups we're in seem to sort of think that some of these potassium silicate timber paints are quite good and do allow a degree of vapor permeability. But yeah, I think there's lots of the modern materials are not very good. A very few number are.
Would you also, just thinking that some of the fungi needs a certain environment and it needs a warmer environment, you've told me before, to actually start producing. And would you say then that some of this issue could be a combination of your property being damp. But then if the heating's cranked up, then it's created this environment which is ideal for fungi. Is that before central heating came into play in the 19th century, that fungi may have not had the environment to reproduce? Would you say, or not?
I don't remember talking to you about temperature. There is an optimal temperature level that fungi can grow in and reproduce in, but they can do it down to quite low temperatures. It's the high temperatures that they don't like. But the main thing that will feed a fungus is stable high humidities. So obviously temperature affects the humidity. So they react, what's the word? Converge. So if temperature goes up, relative humidity goes down.
Yep.
And the other way around. So heating a building will actually help you with fungus, because heating a building will reduce the relative humidity.
Okay.
Which is less favorable for fungi. If you drop the temperature, the relative humidity will go up. And then relative humidity is like 75, 80%. They'll start to be beneficial for fungi. But as I said, it's the fluctuation. Molds could probably take fluctuations. So like if the relative humidity is going above and below 75%, molds can still hang on. For a good fungal growth to sort of start traveling along a wall and maybe jumping onto a wet timber, that would need to have a sort of sustained elevated relative humidity.
Okay.
As I said, it's not so much the temperature as I mean, there are optimal temperature. I mean, I think fungal growth stops at, I forget what it is. I think it stops at close to freezing or maybe a few degrees higher, and then it'll stop above 33 or 34 degrees. And it does have a sort of like a sweet spot, I think, early 20s. The main thing is relative humidity, and of course, how wet the timber is.
Yeah, that's what I was getting confused with. It was the timber, the moisture content of the timber, rather than the temperature.
Yeah, so the moisture content of the timber has got to be over fiber saturation for a spore to land and germinate. Fiber saturation is about 26, 27%.
And just explain what fiber saturation is.
So fiber saturation is the timber, that the cells of the wood have basically taken on all the moisture that they possibly can, and there's literally no more room left in the cell. So the water sort of like is in like fissures and gaps within the cell structure. So the cell structure is full, basically. At 27%, if you stuck a resistance moisture meter in and it read 27%, that's basically saying the wood cells can't take any more water. They're full up. Can get higher moisture contents than 27. That's free water lying on the outside, lying in the fissures and the fibers. It's not actually bound in the cell structure.
I can see another episode coming on because I love all this, and there's so much to talk about.
Yeah. I was just going to say it's an often misunderstood this thing about timber moisture contents and what they mean, what they don't mean. When you need to do something about it, it's terribly misunderstood.
Okay, so another question here: what would be the most common types of fungi found in period properties, would you say?
Okay, well, if you're talking about softwood properties, it would be something like serpulolacromans, which is called dry rot. Because dry rot is a specialist softwood fungus. You won't find it attacking oak or any other hardwood. It's just softwoods. So it's a common one with Georgian and Victorian buildings where there's they hide the drainage away, and there's lots of like casements and architraves, all with little voids. And as I was saying earlier on, it's all about this sustained elevated relative humidity. And so these cavities, there's a leak somewhere, and the relative humidity in all these cavities gradually rises. You don't see it. And then dry rot fungus can get going because it's essentially evolved on the forest floor. So it's used to moving under, it's evolved under leaf litter. So you've basically mimicked the environment under a forest floor. So that's with softwoods.
And what does that look like, Tim? If you had to identify, how would you describe dry rot looking?
What does it look like?
Yes, what does it look like?
It's got a sort of reddy orange dry rot fruiting body with a white margin. It's a resupinate fungus, which means it lays flat. sort of doesn't have a stalk and a sort of a cowl or gills. It has a merylloid sort of surface, which looks like your ear. That's the fruiting phase of it. And then it has mycelium that it sends out in fans. So you'll see mycelium fans or mycelium sheaths. People do mistake serpulolacromans for other fungi. The main one they mistake it with is Coniophora patina, which is celerot, which grows on softwoods and hardwoods, and it looks very similar to dry rot. The mycelium are darker, but the fruiting body looks very similar to that of dry rot. I mean, those are the two common. I mean,
how do you tell the difference between those two then? If they look similar, what would you say?
So Coniophora has dark brown or black mycelial strands. Dry rot is white.
Okay.
But the fruiting body, the actual reproductive phase, looks very similar. Usually Coniophora patina lays flatter, and the color difference between the white margin and the brown fruiting body is slightly different to that of dry rot, but you got to get your eye and you got to know what you're looking at.
Yeah. And any other fungi that you could find?
Yeah, you get things like Astrostroma growing a lot, which is another recipienate fungus. Astrostroma means star body. It's a wet rot fungus. I mean, yeah, I suppose we should talk about the terminology of fungi. It's a ridiculous nomenclature calling it dry rot and wet rot, because dry rot only applies to serpulolacromans. So you're characterizing your fungi by one fungus over here and all the rest over here. That's sort of like a stupid way to divide it. But people have been using the term dry rot for years. So that one's dry rot, all the rest are wet rots. But yeah, there'll be things like Astrostroma, there'll be things like Caprinus, which is the inkcap fungus you'll see a lot, and Trodia valentii, you'll see a lot with softwoods.
But am I right in saying that dry rot is the most sinister?
Not necessarily. Given a certain set of very specific environmental conditions, it can be particularly vigorous and has got quite a fast growth rate. Possibly fast, given lab conditions, it's probably got, in terms of millimeters per day growth on an agar plate, optimum conditions. I think dry rot's probably the speediest. But no, I don't. I think people make a lot of, oh my God, it's dry rot, and oh, thank God, it's only Coniophora patina, it's only celerot. You know, it's not like that. They're both timber decay fungus. Unless you do something about the water and getting this timber dry, both they're all going to cause you a problem.
Okay. Now, same sort of question, the most common types of wood-boring insects would you find?
So in this country, I mean, the ones we all know, so there's Zestobium rufovillosum, deathwatch beetle. That's found in hardwoods only, usually oak. Then you've got furniture beetle, Anobium punctatum. Those are much smaller beetles. You find them in softwoods and hardwoods.
Is that what people refer to as woodworm?
Yes, I mean, people, again, it's a confusion there, because some people refer to anything that makes a hole in the wood as woodworm. Some people refer just to furniture beetle as woodworm. Some people refer just to deathwatch beetle as woodworm. So again, it's not a term we would use here. You have wood-boring weevil, which are different in the sense of the adult. It's the adults that make the mess as well as the larval stage, as opposed to the anabides, deathwatch beetle and furniture beetle, where it's only the larval stage that does the damage in the wood. The adults don't do any feeding of wood. So it's those three are sort of like the biggies. You get something like Lictus beetle in oak, generically called the powder post beetle.
Oh, yeah.
All of these animals only ever nibble away at sapwood margins. The only way they'll ever get into the structural heart of the timber is if there's already been a decay fungus that's gone through it. So I think these insects, I call them secondary agents. I think they get a bad press because people will think, I've got a problem because of deathwatch beetle. I've got a problem because of furniture beetle. You haven't. You've got a problem because you let the wood get wet. And it's always only going to be a very superficial problem anyway, unless the wood started to decay. So your problem is the fungus, not the wood borer. So those are the handful, the 3 or 4 of the common ones. House longhorn you get in the southeast of England a bit. That's quite a big animal that you get in softwood. Other animals will make a mess of timber, but aren't digesting it. So, like parasitic wasps, colony insects like and common wasp, they will excavate timber to sort of like live in it.
Sorry to interrupt. Am I right in saying that all these insects need a level of moisture to survive?
Absolutely.
Yeah.
Absolutely. If the timber's too dry, the larvae will just desiccate.
Right. And
because
what would be
the
that?
skin's very
Does it
thin.
vary? Does it vary from insect to insect?
Yes, it does. Some larvae are able to sustain more developed larvae, such as the house longhorn. I found them emerging in timber with as low as 14% moisture content.
Mm.
Something like deathwatch beetle or furniture beetle would probably just be able to subsist down to moisture contents of like 16, 17%. Growth would be much better at higher timber moisture contents. That would be in the sort of mid-20s, would be much more conducive. Because the larvae could move through timber at lower moisture contents, but they have difficulty acquiring the energy they need to pupate. So you might find that the larval stage would be a lot longer, as they took longer moving through the wood to acquire sufficient energy.
Mm. And I know this is a bit of a strange one. You probably can't answer it, but let's say you a typical timber framed building, and you went into the central part of the house and you did a moisture reading on the middle of that beam. What would you say? Let's say you did 10 properties. What would you say the average reading would possibly be, right in the center of that oak beam?
Of an old timber frame build. Yeah, it's you've picked a bad example, because historic oak plays havoc with resistance type moisture meters.
Oh yeah, that's right.
So there's a picture on my website of me sort of like with a resistance moisture meter in perfectly good dry oak showing 100%. It's thought, I don't think there's been any research done on it. It's thought that it's due to distribution of tannins in the timber. As the timber's dried, the various extractives will sort of like move through the timber in different ways and deposit in veins, like in marble. And you stick the moisture content in, and the electrical resistivity properties of those veins of extractive are very different from the wood fibers. So I'd say that you need to treat it with caution with oak.
But if you could find the actual reading in those 10 properties, the accurate reading, what would you say it would be? You know, as low as 10, as high as 20?
Oh, I see. Well, did you say the middle? If your electrical resistance is representative of the moisture content of the timber fibers, you would expect it to be anywhere between sort of unreadable, which is anywhere below 8% is unreadable. If it was in contact with the ground floor, you might expect it to go up to sort of 20 or something. If you come away from the floor, you'd probably expect it to drop down to sort of 12 to 15 to 16, maybe. Yeah. Bit up high in the ceiling where it's drying a lot more and it's kept warm and dry a lot of the time, it might become unreadable. You might be looking at 10 to 14 or something.
Yeah, but I suppose what I was trying to get at is for people that own period properties and timber framed buildings, to give them an understanding. If their house is damp and the moisture levels are quite high in their beams, then it's going to be a possibility that it could suffer from insect infestation. If it's well maintained, then it's unlikely. If it's well maintained and there are no sort of real problems with the roof and water ingress, then it's going to be unlikely. Because I think a lot of people, they buy a period property with a timber frame, all these wonderful beams, and they immediately start panicking because they see all these old woodworm holes or deathwatch beetle holes that are probably 200 years old, but they're constantly thinking, well, could this erupt at any time? What have I bought here? Type of thing.
I say this to everybody that will ring me up, and they'll say, during the flight season, I found some deathwatch beetle on the floor, and I've identified them and I know exactly what they are. And I say to them, having a residual population of wood, if you own a building that's over 200 years old in this country, and it's got timber in it, it's more likely than not that there will be a residual population of wood borers somewhere in the building. You'll never be able to stamp it all out if that's what you want to do.
Mm.
There'll always be a little dark corner of a timber, then a drip coming in from the eaves that's done it for years and years, just wetting up a little sapwood edge of a post in the dark. And you'll have a sort of like a little population of death watch beetle just clinging on in that corner. And every so often one will find its way out through a crack in the wall and land on your windowsill or your bed or something, and you'll see it. The buildings can take it. This has always happened with the building, you know, that if you have your 400-year-old timber frame in the Cotswolds and you see some death watch beetle have probably been coming every year for the last 400 years. It just goes with the territory. All you've got to do is make sure that the timbers aren't wet to an extent where a fungal spore could germinate.
Yeah.
So as soon as you get 26, 27% fiber saturation anywhere, you've then got a fungal spore that could potentially germinate. Now the fungus can then start breaking down the chemicals in the heartwood. That's something that the insects can't do alone.
Mm. That's interesting. That's sort of my next question, but can you, we're sort of coming towards the end, but can you just give some examples of incorrect advice and the wrong treatment given that you commonly see?
Well, the biggest one I see is knee-jerk reaction to, well, we're not quite sure what's going on here, but let's do a belt and braces treatment with a biocide or an insecticide. Mm. People can't seem to realize that everywhere an ecosystem is really important. And as soon as you start doing a scorched earth policy with an insecticide, you're going to kill everything. But they would say, well, that's all right. That's belt and braces. Just as long as everything is completely wiped out, then we're going to be okay, aren't we? No, because if there is a residual population of wood borers living in the timber, if you come and spray everything with a very potent insecticide, you're going to kill all of their natural predators, things like spiders, beetles, centipedes, millipedes. These guys are incredibly effective predators of emerging beetles. So if you go and start sort of slapping chemicals over a problem that you don't understand, thinking, well, this is just belt and braces, I can't make it, I'm not going to make it any worse. You very possibly are going to make it worse. You'll be compounding or even initiating a problem that wasn't there previously. You're just upsetting the eco balance. As I said, talking specifically about insects, most buildings have residual populations of insects, wood borers living in them, always have had. Mm. But nature controls itself. You know, the insects will emerge, the spider jumps on it. If you start killing all those, and I see blunder traps, they drive me nuts. You see them in a lot of National Trust properties. And every National Trust property, I will talk with the wardens and say, and you open one of these blunder traps up, which are sticky traps. The idea is that if there's any moths that could hurt their collection, or any death watch beetle or furniture beetle sort of blundering around the corner of the room, they get stuck to the trap. And it's great because you can monitor it, open the trap up. Oh, we've got a moth here. We know we've got moths in here. That's killed one of the moths. There'll also be 5 or 6 spiders stuck to the same trap. So a predator is a very active animal. You know, something like a house spider will patrol the whole of your ground floor every night and jump on and kill anything smaller than itself. They are incredibly effective, like home protectors. And we routinely kill them, not understanding what they're doing. So I think, yeah, your question, do I ever routinely see things done? It's this idea of use of biocides and insecticides as a sort of like a coverall belt and braces, horrendously harmful. And I know when somebody's used it, even if they say they haven't, because I'll be crawling around in their roof space and there's nothing there. It's a desert, it's dead, which isn't necessarily a good thing. It might be to them, they might think it was great. I've got one creepy crawl in my roof void anywhere. That's not a good thing.
Yeah, that is very interesting you say that, because we are just so used to seeing an insect in our house and panicking and throwing it out the window, whereas, you know, we're living with them. We have been living with them for thousands of years.
Yeah.
And, you know, it's part and parcel of it. I've got a couple more questions. Are there any sort of really big challenges facing your profession today, would you say? Or what, if there are, what would you say they are?
I think there's lots of this idea. I mean, it's in the timber world, the damp world, not so much so like damp problems and timber problems. Years ago, I started working with my old boss, Brian Ridout. He started in 1987, and he said to one of his technicians, Phil, who I knew, sort of like 5 or 10 years later, he said, we'll be out of a job in a few years' time. As soon as everybody realizes what's actually happening, they're not going to need us to tell them that, and we'll just die a death. And how wrong he was. That's a problem, because it means that the word's not getting out. The biggest problem we're facing as a profession is not being heard.
Yeah.
So right now, there are people going around flushing high listed buildings, poisons and chemicals, chopping out timber that doesn't need to be chopped out, drilling electro-osmotic damp proofs into historic buildings, flood irrigating masonry because a lintel underneath a gutter decayed, and so they're drilling holes everywhere, flooding it with irrigation fluid, by a fungicidal fluid. All of this is like horrendously damaging stuff that was done in the 60s and the 70s. And we thought through the first generation building conservationists that would stop to that. It hasn't. And if anything, for some bizarre reason, it seems to be gaining traction again.
Oh,
I don't quite know what's going on.
The last question I've got for you is, what's the best advice that you can give to both professionals and homeowners when it comes to dealing with, timber or preventing it, I'd say?
So I think that there is some self-help for them, rather than me saying, ring us up. I think understand timber moisture content. You can get a timber moisture meter for about 150, 200 quid, a good one, Protometer one or something like that. Get yourselves a good timber moisture meter. And then it's just a question of reading up on timber moisture contents and what material the timber is, and what, if you have found an insect, what the insect is. I mean, the internet's an amazing resource. You can even just, like, if there's a fungal growth growing in your building, in your basement or something, you want to find out what it is. There are sort of like apps that you can take a picture of it and it will identify it for you. There's a lot you can do before. I'm not trying to do myself out of a job here, but I mean, there's lots of self-help you can do. It's basically just understanding if there is a problem or not. So understanding the moisture content, understanding the substrate, the wood, understanding the organism that's interacting with it, and then sort of drilling down into those three things and then forming a picture of the whole thing. If you knee-jerk panic and say it's got to be killed, cut out, stopped, ring up, and they will quite happily come around and cut your floor out and pump your house full of horrendous stuff. But yeah, there's lots of stuff you can do on your own.
Fantastic. Well, thank you so much, Tim, and thanks ever so much for sharing your expertise with us today. Your insights have been incredibly valuable, so it's been amazing. But before we finish, are there any resources, or such as books or websites, organisations that you'd recommend our listeners to go and take a look at?
Well, there's going to be the hopefully Heritage Network. Yeah, as that sort of like
Heritage Buildings Forum. Yeah,
Heritage Buildings Forum. I mean, my website's got quite a few bits and pieces on it, but no, it's difficult, because if you do want to start drilling down into it, if you're just going to look at fungus, building mycology is huge in its own right, and if you're just going to look at insects, building entomology is huge, building science is huge. So it seems such a simple subject, but there are huge areas that all overlap in the big sort of Venn diagram scenarios. All of the information's out there. If you want to go and download various papers on what fungi can and can't do, what insects can and can't do, strength, durability of farmed versus naturally grown timber, it's all out there. But yeah, it's difficult to pin down exactly what you want. So yeah, difficult one.
Brilliant. That's been so helpful, Tim. Thank you very much again. And I'm definitely going to get you back for another episode.
Oh, sorry, I should have said, of course, there's the English Heritage volume, Practical Building Conservation series.
Absolutely.
That's I mean, that's the best and biggest resource I'm aware of. And the timber one there was edited by my old boss, Brian Ridout. Yeah, very concise.
I'll get that. 2 seconds.
There she blows.
Yeah.
There she blows. Yes.
Absolutely.
Big old tome.
Invaluable. Brilliant. Okay. Thanks very much, Tim.
Okay, Vincent. Good talking to you.
Thank you. Bye-bye.
Bye.